Hi, in this video we are going to implement the WebCrawler together with the help of Bradford Search. So let's get started. I'm going to create a vertex class. It is approximately the same as we have seen the algorithm for Bradford Search. We will have a vertex. It is going to store strings and names. It is going to be the name of the given URL or the name of the website we are going to crawl. So a web crawler is something like that. We start at a given web page. We examine that whether there are other links to other websites, and we keep visiting these links, these web pages. And this is how we find out the structure, for example, of the web. So for example, Barabási Albert László made a model, and with the help of this web crawler, he and his team was able to make some calculations concerning the structures of the World Wide Web. So something like this is the web crawler. So we have a private boolean visited, whether we can check with the help of this flag whether we have visited that given web page or link or not. I'm not sure, but I'm going to store a reference to the previous vertex. Then I'm going to have a list of vertices. It is the neighbor list, or adjacency. I'll call it adjacency. It is a bit better name. Adjacencies list. In graph theory, we called the neighbors adjacencies. Okay, I import the java.util.list, and of course I'm going to have a public vertex, not like that, vertex string name. This dot name is going to set to the name. I'm going to instantiate this array list. Okay, like that. And I'm going to have a public void add neighbor with vertex this dot adjacencies list dot add dot vertex. Source generate getter setters. I'm going to generate the getters and setters for this with the help of the IDE, and of course I'm going to override the toString method. I'm just going to return this dot name. It is the name of the website, so we keep jumping from websites to website. We keep visiting the neighbors in a Bradford manner. So this is why it's this web crawler relies heavily on Bradford Search, and that's what we want to solve this problem. Then I'm going to have another class called BFS. In this BFS, I'm going to have a private queue for vertices, of course. This is the queue. I'm going to have a list of strings. This is the discovered websites list. So discovered website list. Then in the constructor Bradford Search, I'm just going to instantiate the queue. It is a new linked list. We don't have to specify it's a vertex. Okay. And this that discovered list, it is going to be an array list. So I have to import, of course, the java.util.list. Okay, so I'm going to have a public void discover the web method, and of course I have to start at a given root node, but this root node is not going to be, for example, a number, but a website. So it is basically the same as we have seen in Bradford Search. the previous video, this was the BFS method, but here, because we discovered the web with the help of breadth-first search, that's why I give the name discover the web. And of course I have to start at a given point. So this .q.add, I add the root node to this queue, and I add to the discovered websites. I add the root node, yes. And while the queue is not empty, I just string, for example, v is a vertex, this .q.remove. Then I have to get the row HTML, and I can do it with the help of the read URL method. I'm going to create it, so I will have this method read URL create method, and I'm going to implement it. It's not going to take very fast. I just have a string row HTML. Okay, I'm going to have a try-catch block. It is not a good programming practice to catch all the exceptions, but I'm going to do this just for demonstration purposes. We should specify that whether it's a runtime. So we have to specify the exception. It is not a good programming practice, but I don't want to take a lot of time to write the exceptions and so on. Okay. So I'm going to have a URL, a new URL with the v string. Then I have a buffered reader, because I have to read data from this URL. New buffered reader, new input stream reader. Of course, I have the URL that opens stream. This is a typical and beautifully constructed design pattern. If you are interested in it, I have a video about how to use these kinds of design patterns. It's a very nice implementations of how to add new features to the existing one with the help, I mean through the constructors. Okay, anyways, it works. That's all that matters. This is the so-called decorator pattern, by the way. String input line is equal to that, and while the input line is equal to the buffered reader, that read line is not equal to null, then the row HTML plus equal to the input line. Okay, so we close the buffer reader, and then we return the row HTML. So why do we need the HTML? Because then we have to find the links in this row HTML. So everything that starts with http://www.google.com, for example. So we can do it with the help of regular expressions. What's the problem? Maybe, yes. It's a string. Yeah, it's a, sorry, it's not storing vertices. We are storing strings. Okay, the website names. So we have read the URL, then we have the regexp is equal to everything that something like this. It starts with http:// and it has 3 W's. Yes, something like this. It is a regular expression that enable us to find all the URLs in a given row HTML. So we have the pattern equals to pattern that we have to compile the regular expression. Then we have a matcher equals to the pattern that matcher and the row HTML. Okay, and while the matcher that find, we have to find these links, then the string v is equal to w, because the v is already used, the matcher dot group, and if not the discovered websites list that contains the w we have visited now, then we add it to the discovered list. And of course I write that website found and plus the v. I specify that website found with URL plus v, okay. And of course I have to add it to the queue. Oh, sorry. The queue dot add. I have to add it as we have discussed in breadth first search, because this is basically a breadth first search, but here we do not dealing with vertices. We are dealing with strings that represents URLs. So let's check whether it's working fine or not. We have an app, we have a main, and for example I have the string root. It's going to be a website. It is going to be the website of my former university, alta.hu, because it's Hungary, not com. But you should use www.google.com or whatever you prefer. I just use ELTE, and I have to instantiate the BFS, and BFS that discover the web from this route, so from this website. So if I run it, they may be links where we are not able to connect because server errors, because they may be deprecated links on given websites. So no surprise. And found this, found these kinds of URLs, and it keeps going and going layer by layer, as we have discussed in the theoretical section, and keeps listing all the websites that is reachable. And yeah, there's a IO exception because the server, we are not able to connect to that server. There's a server problem. Okay, it may be, and maybe there's a read URL. Yeah, but it keeps going because we are not dealing with, I think, whether there's a server error. We are not going to deal with that, so maybe we should update our code. But I think that the main point is that we are able to construct an algorithm that can discover the web in a breadth first manner, start at a given website. In my case, it is the alta.hu, and we keep getting, with the help of this regular expression, we get a row HTML, we get all the links, and we keep visiting these links, and then the links on these row HTML files, and so on. So we keep discovering the web in a breadth first manner, and this is how web crawlers works in practice. Thanks for watching.